Alright, this is the second video in the infinite series series of videos. We're going to be looking at geometric series. If your common ratio is not 0, then the sum n equals 0 to infinity of ar to the n. That is equivalent, the sum n equals 1 to infinity of ar to the n minus 1, which looks like a plus ar squared plus ar cubed plus dot 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 plus ar to the n. It keeps going. If the absolute value of your common ratio is greater than or equal to 1, then the series diverges. If the absolute value of r is less than 1, then the series converges. For the absolute value of r less than 1, then the sum n equals 0 to infinity of ar to the n is equal to the limit of, we forgot something here, the limit of s of n, which is your partial sum, which is equal to the limit as n goes to infinity. That partial sum is going to be a times 1 minus r to the n all over 1 minus r. And then using properties of exponentials, r to the n is going to go to 0 because the common ratio is less than 1. Now that r to the n, if the absolute value of r is greater than or equal to 1, specifically greater than 1, then that's going to cause the partial sum to behave quite wildly, and so that would diverge, and so we'd say the series diverges. If the common ratio is 1, then we have 1 plus 1 plus 1 plus 1 plus 1, and so that's going to diverge. That's going to be a infinite sum of infinity. So let's look at a couple examples. We're going to write a couple of series into their summation or sigma notation, and then we'll determine whether the series converges or diverges. If the series converges, we'll find the limit or the sum. So let's look at 1 plus e over pi plus e squared over pi squared plus e cubed over pi cubed plus etc. So that's going to be the sum n equals 0 to infinity. First term is 1, and then we have e over pi as your common ratio. Okay, so that is our series there. If you want to start it with an index of 1, you certainly can, and so you need to dial back the exponent by 1, so n minus 1. Okay, the common ratio and absolute value is equal to e over pi, which is about 0.87. That is less than 1, and so that common ratio and absolute value is less than 1, and so we have a convergent series. And so the sum n equals 0 to infinity of e over pi to the n power. We're going to go ahead and put our generic formula up. The sum n equals 0 to infinity of a r to the n. And so we're assuming this is a geometric series. Converges to a over 1 minus r. And so our particular example will converge to 1 over 1 minus e over pi. If we multiply the numerator and denominator by pi, we'll have pi over pi minus e. Okay. All right, let's look at the next example. This one's a cool one. We're going to look at 0.36 bar repeating. So 0.36, 36, 36, 36. So that's going to be 36 over 100 plus 36 over 10,000 plus 36 over 1 million plus 36 over 100 million, and etc. Okay. Your first term is 36 over 100. The common ratio, maybe you're able to notice that it looks like we're adding 2 zeros onto the denominator each time, so that'd be multiplied by 100. So what we can do, because it's a geometric series, is take 2 consecutive terms, so the first and the second. We'll take the second and divide that by the first. Keep flip change. And so that gives us a common ratio of 1 over 100. Or we can grab the middle two, the second and the third terms. We'll do that also in just a moment. So the absolute value of the common ratio is 1 over 100. And that is less than 1, so this is going to be a convergent series. So if we take the second and third ones and take the third one and divide that by the second one, keep flip change. And we see that is also 1 over 100. And so that's our common ratio. So we can write our sum, n equals 0 to infinity, of the first term, 36 over 100, times 1 over 100 to the n power. And of course, if you want to start it at 1, you certainly can. So it's going to be 36 over 100, sum n equals 1 to infinity, 36 over 100, times 1 over 100 to the n minus 1. So that's going to converge to a over 1 minus r, so 36 over 100 divided by 1 minus 1 over 100. So it's going to be 36 over 100. 1 is 100 minus 1. Sorry, 1 is 100 over 100. So 100 over 100 minus 1 over 100 is 99 over 100. And then we'll keep flip and change. And so we'll have 36 over 100 is what our series sum is, and that'll reduce down to 4 over 11. And then you can be my guest and stick 4 over 11 into your calculator, and you're going to get 0.36, 0.363636, etc. All right. I think we got 2 more examples here. So example number 4, we're going to look at the sum n equals 0 to infinity. 3 times negative 1.01 to the nth power. Our common ratio and absolute value is going to be 1.01, and that is greater than 1. And so this is a divergent series. And that's it, it's a divergent series. I've gone ahead and added in a real brief scattergram, and we can see the divergent behavior. So in blue is the sequence 3 times negative 1.01 to the n, okay? And so you see it has 2 different parts, okay? Okay, and so that certainly is diverging. Converging means it's going to go to the same place, so your points would be coming closer and closer to a certain line, but you can see that they are actually going in opposite direction. And then in orange, I've done, so at 10, that's the first 10 terms, first 20 terms, first 40, 30, sorry, 40, 50, etc. And you notice that it's bouncing back and forth, bouncing back and forth, bouncing back and forth, and it's slowly getting worse and worse, and so that's a divergent series. It's going to take a long time to diverge. So I think I went all the way out to 57. So if you went even further, it's gonna get progressively worse, and so eventually it's going to oscillate from very large positives and very large negatives, and so this is definitely going to be a divergent series. Okay, let's look at one more here. And we're going to look at the sum n equals 0 to infinity of negative 1/5 to the nth power. The absolute value of the common ratio is going to be 1/5, which is less than 1. And so that's going to tell us by the geometric series test that this is a convergent series. And that's going to converge to the first term, which is 1, and then 1 minus the common ratio, over 1 minus the common ratio. So it's going to be 1 over 6/5, or 5/6 is going to be the sum of the series. Okay, so stick tuned for the last video on this section, and that's going to be on the telescoping series. All right, and we'll see you next time.